8-sided polygon A, B, C, D, E, F, G, H has integer side lengths. It can be divided into a rectangle and square as shown. The area of the square is greater than the area of the rectangle. The product of the two areas is equal to 98. Which of the following could be the perimeter? So 98 is the product of the two areas. Okay, well, let's try 2 times 49. That makes the most sense to me because ABCD is a square, so it's got to be such that it has all sides the same. So 7 and 7 would give me 7 times 7, which is 49. And therefore, this little guy, has an area of 2. And since everything's an integer, this has got to be 1. And this side is most likely the 2. So now we can easily figure out the perimeter. That's 7. That's 7. That's 7. That's 2. That's 1. That's 2. And now we just have to figure out that and that. Well, this whole side from A to D is 7, but you're subtracting this 1 guy, that dashed line. So that's going to be 6. This and this combined. So the total perimeter looks to me like 7 plus 7 plus 7 plus that 6 plus the 2, 2, and 1. Hopefully that is right. So that's 21, 27, 27 plus 5 is 32. And therefore 21 would be B. A Gareth sequence is a sequence of numbers in which each number after the second is the non-negative difference between the two previous numbers. For example, if a Gareth sequence begins 1512, third number would be 15 minus 12, which is 3. Fourth number is 12 minus 3, which is 9. Fifth number is 9 minus 3, which is 6. And so resulting sequences 15, 12, 3, 9, 6, so on. If the Gareth sequence begins 10, 8, what is the sum of the first 30 numbers? Okay, so let's make the sequence 10, 8. The next one would be the difference between 10 and 8, the positive difference, or non-negative difference. Same thing, I guess. That's 2. Then the next number would be the non-negative difference of those two guys, which is 6. And the next 2 would be the non-negative difference of that, which is 4. Non-negative difference of 6 and 4, which is 2. And let's just keep going like this. So we got 2. I'm not going to talk you through it. I'm just going to do it manually. 0, 2, 2, 0, 2, 2, 0. Okay, so I get a pattern here. Okay, so if I get a pattern, first of all, let me put in 30 dashed lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, I'm going to stop here. I just did that so I know when to stop. So it looks like it just it repeats 2, 2, 0, 2, 2, 0, 2, 2 like that. Got it? Okay, so either you just repeat it or just do it manually, up to you. Doesn't really matter. So 2, 2, 0, 2, 2, 0, 2, 2, 0, 2, 2, 0, 2, 2, 0, and 2. Okay, now all I have to do is just add up these numbers. And when you add up all these numbers, you will get 64. And therefore, number 22 is E. The digits 1 through 9 are each used exactly once to write the 3 one-digit integers and 3 two-digit integers. The one-digit integers are equal to the length, width, and height of a rectangular prism. The two-digit integers are equal to the areas of the faces of the same prism. What is the surface area of the rectangular prism? We have some rectangular prism, and it has, I'll just call them A, B, C, as the length, width, and height. And then the surface areas, of course, that's going to be A times B. So that's going to be A times B multiplied. And this side is AC, and that side is BC. So those are the surface areas. BC, like that. B times C is what I should be writing. And we have to somehow figure out what these numbers are based on the fact that the digits 1 through 9 are all being used, but only once each. So we have to mix and match, but it's very time consuming, so we have to have some sort of rules, something that will help us. So the first thing I noticed is that A, B, and C, these three guys over here, none of them can be 5, can't be a 5. And I said, well, why? Because if, let's say A was 5. So for example, if A was 5, then you'd have to multiply it by B in order to get this guy. Now, whatever B is, let's say B was 7. So AB, A times B, I should say, would be 35. Now that's a problem because that's a 2-digit number, but you have a 5 in it, and you can't use the 5 more than once. You've already used it once, so you can't use the 5 more than once. So that's why none of those can be a 5. Got it? So I'm kind of going through this step by step to see what we can do. Okay, so move on. Now the 5 has to go somewhere. You say, well, it can't be one of these guys here. So it obviously has to end up in one of these numbers. So it has to be something like one of these guys here has to be has to have a 5 as its 10th digit. It's impossible to have it as a 1's digit for this reason here. So it can be based on the numbers here. How do we get a 5? I think the only way is either a 9 times 6, which would be a 54, or a 7 times 8, because we're very limited with regard to what we can use, and that would be 56. Okay, so we've got a couple of choices. We're not sure which one is right, but at least we know, so we have at least 2 choices that we can go with. So let's just work with this guy first, and let's see if that's the correct one. If it's 7 times 8, then that means that's 56, right? So that means that what we have done is for this A, B, and C, we've chosen one to be 7, one to be 8. And for this A, B, AC, and BC guy, AB, we have done this 56. Correct? Okay. All right, so now we have to fit the pieces of the puzzle together. What I mean by that is that we have to now fit in all the other numbers to see if this can all work out so that we only use each digit once. Okay, well, can this C right here, can it be a 1? And the answer is no, because if it was 1, this AC would become 7, and you can't have a 7, well, first of all, because it's a 1-digit number, so 1 is out. How about, can the C be a 2? I'm just going through it. Well, let's see. If it's a 2, then this B, let's see here. If it's a 2, this BC would become 16, and that's not allowed because we've already used the 6, so you can't have a 16. Okay, so that's gone. How about if C was a 3? If it's a 3, let's see, it'd have 21, 24. Is that good? Does that work? Let's see. If it's a 3, no, because the 21, this would be 21 and that would be 24, and the 2 would be used twice, so that's no good. How about a 4? If it's 4, you'd have 28 and 32, but the 28 has a 2 in it and the 32 has a 2 in it, so you can't use the 2 twice. And have I exhausted everything? 1, 2, 3, 4, 5, 6, 7, 8. Oh, I think I have a 9 left. Yeah. If it's a 9, then you'd have 63 and 72. But 63 cannot be possible because you already have used up the 6. So that's it. So therefore, this example, no good. So this is the only one that can work. 9 and 6. Okay, so that's pretty decent. We're almost done. So I put this as a 9, I put this as a 6. And then we got AB, AC, and BC. So AB is 9 times 6, which is 54. Okay, so we've used up a 9, we used up a 6, we used up a 5, we used up a 4. Okay, so now let's see. We have to now experiment to see what is the last number. Check the remaining digits, Okay, I'll let you check it, manually, just like how I did over here. All this stuff that I did over here. I'll let you check it. And when you go through the remaining digits, you'll find the only one that works is a 3. Because if it's 3, then AC becomes 27. And if it's BC, it becomes 18. So 3 is used once, then the 2, then the 7, then the 1, and the 8. And there you go. So that is how you would do it, I guess systematically. Now we're still not done. We still have to figure out the surface area of the prism. Surface area would be these 3 guys times 2. So add them up and multiply by 2. And when you do, you will get 198, and therefore the answer is D. A circle is divided into 6 equal sections. Each section is to be colored with a single color so that 3 sections are red, 1 is blue, 1 is green, and 1 is yellow. 2 circles have the same coloring if one can be rotated to match the other. In the diagram, figure 1, figure 2 have the same coloring. Figure 1 and figure 3 have different colorings. How many different colorings are there for the circle? Okay. So we have to sort of break this up into, I think, 3 groups. And then we'll discuss what are the options. So the first group is when all the 3 reds are together. So you have red, red, red like that. Now we have what? Blue, green, and yellow. And those 3 colors obviously will fill in the other spots. And very quickly, you can figure out that you can do it as yellow, blue, green, or yellow, green, blue, blue, yellow, green, blue, green, yellow. And then the last one would be putting the green first. So green, blue, yellow, or green, yellow, blue. Meaning that's what you'd put here. For example, you'd put yellow, blue, green like that. That would be one example. And then these are the other ones, how the other 3 colors would be placed. So that is 6 possible ways. Okay, so that takes care of that scenario. Another scenario is when you have 2 reds together. So red, red, red like that. And then 1 red is sort of like that. And another way is similar. So you have red, red, but then the other red is like that. Yeah. Because if you can't put them there or there, because that would be 3 reds in adjacent to each other, which would be the same as this guy. Okay, so this guy, same story really. Same thing. Now you have to figure out, how do I place the yellow, blue, and green? And it's in the exact same way as we did up here. So for that one, you'd have 6 ways. And for this one, same thing, 6 ways like that. Yeah. Okay, moving right along. There's one final way, and that is if all 3 reds are separate, meaning like this. Yeah. For this one, you might be tempted to say, oh, is it the same thing as up here again? But no, there's only 2. Since there's only 2, I'm going to actually draw them. I'm going to draw them like this and like that. Okay, so let's put in the red, red, red like this. And then we're going to put in the yellow, blue, and green. So we can have one scenario like this, green, blue, yellow. Or you can have green, yellow, and blue. Yeah, because everything else would be the same. Because they mentioned that in the question also, I think. If you rotate, something about rotating. Yeah, if you can rotate it to 2 circles have the same, if you can rotate it to look the same. Yeah, so you got to be careful. These are the only 2 unique. So we got 2 there. And therefore that's it. 6, 6, 6, and 2. I believe that adds up to 20. And therefore, number 24, the answer is E. A school trip offered in its participants 3 activities: hiking, canoeing, and swimming. Attendance records show that all of participants, 10 students participated in all 3 activities, 50% participated in at least hiking and canoeing, 50%, so 60% participated in at least hiking and swimming. K participated in at least canoeing and swimming, and no student participated in fewer than 2 events. If K is a positive integer, what is the sum of all possible values of K? Okay, so we're going to have to use something known as a Venn diagram, and I'll explain what that is. First of all, let me write down what the name is: Venn diagram, and I'll explain. So first I'm going to write 3 circles, and let's explain this now. So this circle over here represents the hiking. That's why I put an H there. Circle on the right, well, whatever you want to call it. I'll just denote it as swimming, and the one at the bottom I'll call canoeing. Okay. Now, the overlapping regions indicate how many have done both. So, for example, this region right here, let me use a different color here. This region, since it overlaps both H and S, it represents how many students did both, hiking and swimming, and so on. Now, the region in the middle, which kind of overlaps all 3, that would represent all the students that did all 3, hiking, canoeing, and swimming. So let's fill in what we can. All 3 is 10, so that goes right there. 10 goes here. And then 50% participated in at least hiking and swimming. Okay, so that unfortunately is not a number, so I've got to think about what I can do here. I actually don't know how many students are in total, so I'll just call that N. N students in total. And I know for sure that that number's got to be greater than 10, since 10 students participate in 3 activities. There has to be at least 10 students total. I'm sure it's more than 10, but at least 10. Okay, so then I don't know what anything else is, so I'm just going to denote it with letters. I'll call this region X, this region Y, and this region Z. And the good news is this one right here: no student participated in fewer than 2 activities. So they're basically, what they're saying is no student participated in just 1 activity. So this region here is 0, and this region in here is 0, and this region in here is 0. When I say that region, I'm talking about this part, not the full circle, just that part. Okay, so now let's try to make sense of this. Let's go back to this one right here. 50% participated in at least hiking and canoeing. So hiking and canoeing is this guy right here, that whole thing. Let's use green here. So hiking and canoeing is that. So that's X plus 10. 50% of all the students. So that would basically be, what would it be? N over 2, right? Yeah, 50%. Okay. That takes care of this guy. We've done this guy. We've done this guy. Now let's look at this one. 60% participate in at least hiking and swimming. So hiking and swimming would be this region, I believe. So that means Y plus 10 is 60% of the total. So that would mean, in terms of a fraction, what's that? 3n over 5, I believe. 60%. Yeah. And then finally, this guy, the K percent. Okay. So what color can I don't want it to get confusing, but this is the region basically. That is Z plus 10, and they're saying that's K percent. So it's basically K over 100 times N. Right? Because if it was 50%, it would be 50 over 100 times N. Okay, so this is the algebra, and let's see what we can do. All right, so where do I proceed? I think what we have to do is make a table. So we got N and then plug in values, X, Y, Z, And then eventually we'll be able to figure out k, which from this equation I can deduce is going to be 100 times z plus 10 all divided by n, I believe. Yeah, I just rearranged this equation over here. Okay, so that's what we're going to have to do. And just start plugging in values. And then what we do is we add up all the values of k, because that's what they want. What is the sum of the values of all k? But before I start adding or plugging in values for n, you might say, well, do we have to do 10 and then 11 and then 12? And this is going to take forever. And also, when do you stop? Eventually, I think you would stop when k no longer makes sense anymore, because I believe k will go down in value. But let me explain. So, no, you're not going to have to do 10, 11, 12. That's way too time consuming. You can look at these fractions, and that will help you. N over 2 is equal to x plus 10. X is an integer, 10 is an integer. So therefore, n over 2 has to be an integer. The only way that can be is if n is divisible by that 2. Divisible by 2. Similarly, this guy, 3n over 5 has to be an integer, and the only way that's true is n is divisible by 5. So n is divisible by 2, it's also divisible by 5, and therefore it would be divisible by 2 times 5, which is 10. So I'll put a little, therefore n is divisible by 10. So what that does is allows us to jump ahead. So we can put 10, and then we can put 20, and 30, and so on. It makes it a lot less time consuming. Okay, so let's do this. I'll just do the first few, and I'll let you guys do the rest. So 10, if you put 10, let's keep the equations on the same page here. Yeah. If you put 10 into this formula here, you would get 5, and x would actually be negative 5, so that's no good. So we don't need to figure that out, because x cannot be negative. It has to be a positive integer. Let's try n equals 20. You get 0, and then when you put it into that formula, you get, I believe, 2, and then z would be 8. And when you calculate k, it's going to be k is equal to 100 times 8 plus 10 over 20, and that is 90. Got it? So let's make this a little neater, like this. And let's see. So I'm just going to keep going. 40, 50, 60, 70, 80, 90, and then 100, and so on. Okay. So you guys know how to do this, right? I just did it for you, so I guess I don't need to manually do it. I'll just fill in the numbers. So this is 5, 8, and 7. And then k will come out to 56.7. But that's no good, because k has to be an integer. Right? So you just keep going like this. And 40 is going to be 10, 14, and 6. K is going to be 40. For 50, the numbers are 15, 20, and 5. And this is 30. For 60, it's 20, 26, and 4. 23.3, so that's no good. And then I think we have a few more. Let's see here. 70 is 25, 32, and 3. And that, I believe, is 18.6. 80 is 30, 38, and 2. And that's 15. 90 is 35, 44, and 1. And that's 12.2. 100 is 40, 50, and 0. And this is 10. And then finally, once you get to 110, you'll actually get a negative value for z. And therefore, k will not be positive. So, and everything after that, you will not be able to get positive numbers anymore. So now let's count only the values of k that are integers. So that's this 90, 40, 30, 15, and 10, I believe. And then we got to add them up. So 90 plus 40 is 130, then 160, 175, 185. So the sum of those guys is 185. And that is what they're asking. So the answer to the final question is 185, and that is B.